optimizer. The problem is simple but pervasive. Capital and yield in Web3 are fragmented. Users chase returns across dozens of chains, manually bridging assets, trusting opaque relayers, and juggling multiple wallets. That friction wastes capital, increases counterparty risk, and excludes most users from efficient, diversified yield. Our solution is OmniYield Nexus, a Casper native coordination hub that turns a single deposit into a diversified, cross-chain yield exposure. Users deposit CSPR into a secure Casper vault and receive a CEP18 synthetic token, OmniYield, that represents a share of an auto-rebalanced portfolio across chains. Crucially, Casper acts as the canonical anchor. Minting, burn accounting, and event receipts live on-chain, so there is a deterministic audit trail. In short, one deposit, multi-chain exposure, auditable accountability. That's the problem solved: simplicity, safety, and scale. Let me walk you through the application and demo. Start at the OmniYield dashboard. The live demo is available at Casper-GPQBCFUB. Manus, space, dashboard. The top of the dashboard shows the big picture: total value locked, aggregate simulated APY, and the current allocation breakdown across target chains. This is the control center for the user. On the left you'll see the deposit flow. Users connect via CSPR. Click, one integration for many Casper wallets. Deposits are recorded on the Casper testnet vault. The UI displays the deposit confirmation and the minted OmniYield balance instantly once the on-chain event is confirmed. The middle panel is the strategies and allocation viewer. It visualizes where protocol funds are allocated, for example, staking on one chain, lending on another, or LP positions elsewhere. In the MVP, satellite execution is simulated, but the strategy manager emits a deterministic payload hash on Casper. That hash is the minimal, canonical receipt that adapters and relayers consume to execute actions off-chain. To the right, the activity feed is live, streaming events through a backend that consumes sidecar SSE and republishes updates via WebSockets. Each line item links out to a deploy or receipt if you want to inspect the transaction on the Casper Explorer. This is how we achieve traceability. Every cross-chain action has an on-chain footprint. Operators and governors use the strategies page to simulate rebalances and run forked simulations. The demo supports a fork mode so judges can replay scenarios without moving real funds. The simulation shows hypothetical yields, gas impacts, and expected slippage before any real action is taken. Finally, the governance tab is role-aware. Role proofs are resolved on-chain via named keys. Governors can propose parameter changes, operators can trigger approved rebalances, and users always retain view access. The UI surfaces status, time locks, and proposal outcomes. Everything is wired to make the demo crisp: deposits, minting, emitted payload _hash events, simulated relay activity, and final aggregated yield updates, all visible on the dashboard in real time. Now the technical details. The full implementation and design notes are in the GitHub repo at github.com/lucolo/casper-omniyield. The README documents the architecture, on-chain ODRA contracts for the vault, strategy manager, and the CEP18 OmniYield token, sidecar SSE for event streaming, an off-chain indexer and adapter, and a Next.js app router frontend. Key protocol primitives include compact payload _hash events instead of bulky payloads. This keeps gas and deploy size low while providing a canonical hash that off-chain adapters can sign and forward. Nonce tracking and used _nonces in the vault provide replay protection. Typed on-chain error codes are emitted as events for transparency and better UX mapping. On the back end, the indexer listens to sidecar events, persists them in a lightweight store, and builds execution envelopes. The adapter simulator accepts envelopes, simulates satellite execution, returns harvest reports, and in the real flow the indexer submits follow-up deploys back to Casper. Developer tooling includes ODRA VM for fast contract tests, testnet deployment scripts for integration testing, and NodeOps Autogen for C/CD readiness. The README also includes testing commands, an OpenAPI fragment for the indexer API, and recommended audit checkpoints such as payload serialization invariance, replay protection, and supply conservation. In closing, OmniYield Nexus is engineered to be bridge agnostic, auditable, and practical. For judges and engineers, the repository and dashboard provide everything needed to verify correctness, replay flows, and reason clearly about security trade-offs.